Hello learners, welcome to SWAM online lecture series on the topic database management system. Myself, Muhammad Ubadullah Bukhari, working as a professor in the Department of Computer Science, Aligarh Muslim City, Aligarh. I am pleased to have you join me today as we explore the fascinating realm of database and database management system. In the next few minutes, we will journey through relational decompositions, lossless decomposition, and lossy decompositions that will form a backbone of modern system. We will journey through a discussion of relational decomposition, lossless decomposition, and lossy decomposition that form a backbone of modern informed system, which is database management system. In the last lecture, we have discussed about the normalizations in detail, why we do normalization, what is the motivation behind normalizations. The main thing in the normalization we have to discuss to remove the redundancy and maintain the integrity and consistency. Different normal forms, example of different normal forms, and the importance of normal forms. I would like to answer the previous questions. The first question is to describe the second normal form in normalization. The second normal form in the database talks is about making sure that all the information in the database is organized well, so we can avoid repeating data and keep everything neat. It helps to make databases work better. To get to second normal form, we need to check if some piece of information only depends on the part of a main thing we are looking at. If they do, we split them into a smaller part so everything connects nicely. In this way, we can avoid mistakes and keep our data organized, making it easier to use and understand. The next question, what is the primary goal of normalization? The primary goal of normalization in database design are to minimize redundancy, eliminate data anomalies, and ensure data integrity. By organizing data into normalized form, each such as first normal form, second normal form, third normal form, the database structure becomes more efficient and resilient to update anomalies. Normalization aims to create logical and consistent data model that facilitate efficient storage, retrieval, and manipulation of information. The next question was, what are the advantage and disadvantage normal form? In the screen you can see advantage, one side disadvantage. Advantage, data integrity, efficient updates, improved query performance, easier maintenance, simplified design. And the disadvantage is that increased complexity, performance overheads, data retrieval complexity, storage space, and normalization overhead. The fourth question was, what is Bussy code normal form and why is it important in data normalization? Bussy code normal form is a stricter form of normalization that addresses certain anomalies not covered by 3NF. In BCNF, every determinant must be a candidate key. It ensures minimal redundancy and eliminates all types of functional dependencies other than those based on candidate key. BCNF is important in database normalization as it further enhances data integrity and reduce update anomalies. The today's agenda is to be discussed. We'll discuss a relational decomposition. In the previous lecture, I have told why we decompose a relation. So here we'll discuss the relational decomposition, lossless decomposition. When you decompose a relation, it may be lossless or lossy. It means you are losing some rows, or you are losing some tuples also. So, and lossy decomposition, we start one by one. Relational decomposition. Relational decomposition is not an appropriate normal form, then the decomposition of relation is required. If relation, I mean to say that when a relation is not appropriate normal form, suppose you want to check whether it is a second norm form, third norm form, whatever. It means the relation is not normalized. How you will understand this data is not normalized? So when you will decompose, first of all you have checked the three conditions, the three anomalies we can say. The first anomalies are, you can say, update anomalies. Second is insertion anomalies. Third is deletion anomalies. If all three anomalies will satisfy, then no need to decompose. We can say this is a normalized database. If the three condition, any one condition will not be applicable to relation, then we can say this is normalized. We have to decompose a relation in such a way that decomposition, you have to check the decomposition. So here, in database, it breaks the table into multiple tables. Depending on the requirement, organization, you have to break into multiple tables. If a relation has no proper decomposition, then it may lead to proper like loss of informations. Decomposition is used to eliminate some of the problem of bad design like anomalies, inconsistencies and redundancies. And then you can say that decomposition, if you are decomposing a relation, then that decomposition is may be lossless and FD preserving. So in that decompositions, if you are decomposing a relation, that decomposition must be lossless and FD preserving. So there are two situations. It means 2 to the power 2. It means 4 situations will arises. The relation may be lossless, FD preserving. Second will be lossless, non-FD preserving. Third will be lossy, FD preserving. Fourth will be lossy and non-FD preserving. If your decomposition is lossless and FD preserving, then we can say this is a good decomposition. All other three, lossy, non-FD preserving, lossy, FD preserving, lossless, non-FD preserving, all three condition is called bad decomposition. So this in the examination assignment they'll ask about what do you mean by decomposition, bad decomposition, good decomposition. I hope you will understand. So the decomposition must be lossless and FD preserving. It means we are preserving all the attributes, and also we are preserving all the rows. You can say domain and the tuples. Then we discuss about the types of decomposition. Here we will discuss about the lossless decomposition. The next is lossy decomposition. We start one by one. The lossless decomposition, it means if information is not lost from a relation that is decomposed, then decomposition will be lossless. The lossless decomposition guarantees that the join of relation will result in the same relation as it was decomposed. It means when you join decompose on some attributes, column attributes, when we are able to find the original table, then we can say this is not decomposed. relation is lossless decomposition. The relation is said to be lossless decomposition if natural join of all the decomposition give the original relations. Then steps of lossless decompositions. Identify the functional dependencies. Check the redundancies. Next step. Apply normalization and verify losslessness and refines as needed. So first I will explain. Identify functional dependencies. It means look at the attributes or the column in the table. Determine which attributes functionally depends on each other. This means figuring out which attributes uniquely determine the value of other attributes. Next, to check the redundancy, it means make sure there are no redundant or unnecessary dependencies among the attributes. Redundancies can lead to data anomalies and inconsistency. So you have to check the redundancy. Next step to apply normalization. Use normalization techniques like Boussicot normal form or third normal form to decompose a table into a smaller table. Each new table should represent a single entity or concept, and each attribute should depend only on the table's primary key. And you have to decompose. In the previous lecture, I have discussed about the normalizations in detail by giving some suitable examples. You have to go through, and then you have to verify the losslessness. After decomposition, ensure that you reconstruct the original table by joining the smaller table using a primary key. This step ensures that no information is lost during the decomposition process. And then refine as needed. If the decomposition results in a table that are too small or too many, or if there are still redundancies, refine the decomposition by adjusting the dependencies or breaking down the table further. It means you have to check. Suppose you have decomposed a relation, okay? Suppose they are relation R. You have applied all the condition anomalies, insertion, deletion, updation. It will not fulfill all the three anomalies. Then you have to check R1, decompose relation R1 and R2. Then also you have to check in R1 and R2. If R1 is satisfy all the three anomalies, if R2 will not satisfy all the three anomalies, insertion, deletion, updation anomalies, then what you will do? You have to decompose also into further. It means R21, R22. I'm taking one example on the screen. You can see this relation is decomposed into two relations. This relation is decomposed into two relations, employee and department. Okay, employee department tables contains the employee ID, employee name, employee age, employee city, employee ID and employee name. Okay, this is one table is that employee ID. There's a here is the 1, 2, 3, 4, 5, 6 attributes are there. Okay, employee ID 2, denim, employee age 28, Bombay, employee department ID 27, sales, like that. Okay. Then you have to decompose relations. You can see on the screen we have decomposed relation 2. In the employee and the department, in the employee table, we have employee ID, employee name, employee age, and employee city. Employee department, we have decomposed employee ID, department, and employee ID and the department. And in department ID, you have to use also, and the employee ID I have used in also table. If you will join by employee ID, then you are able to get the original. Then this is a lossless. Now when two relations are joined to common employee ID, then the resultant relation will become like that. See on the screen you can see I have given screenshot for that. Employee ID, employee name, employee age, employee city, employee ID, department name. Here the 1, 2, 3, 4, 5. 5 tuples. In the original was, see, in the original is also 5 tables. After decompositions, in the first initial table contains only 5 rows, 1, 2, 3, 4, 5. After decompositions, also that. So in this way, we can say this is a lossless. Hence, the decomposition is lossless joint decomposition. Also, we take another example. Let's consider a simple example with a table representing information about the student schools. So, we will go through the steps of loss decomposition to break down this table into a smaller table. So, the step what I have explained you before few minutes, you have to apply and then check. The original table is student ID and the attributes name is name, grade and the teachers. And there are 4 records there. In the first step, I have explained identify the functional dependencies. You check. In this table, we can see that the attributes name, grade and teachers are functionally dependent on the student ID. This means that a given student, we can uniquely determine the value of name, grade and the teachers. Second step, check the redundancy. So there are no obvious redundancies, unnecessary dependencies in the table. In the third, apply normalization. Let's decompose our original table into 2 smaller tables, one for student information and another for teacher information. You can apply third norm form. Okay, student information and the second is teacher information. Here the teacher Smith, John, Thompson and Miss White. The grade is like that. Okay. Fourth step, I have discussed verify lossless. To verify lossless, we join 2 smaller tables using the common attributes. By doing so, we can reconstruct the original here. So we are able to same. The fifth, refine as needed. This example, the decomposition into student information, teacher information seems appropriate and lossless by applying all the 3 remedies. These are about lossless. The next topic is we will discuss lossy decomposition. Lossy decomposition is a method used in database management system to break down a relation into a smaller table, but unlike lossless decomposition, it may result in the loss of some information. It means we are losing when we decompose the relation and then we join by a unique key, a common key, then we are losing the some attribute, you can say tuples. Suppose in the original records there are 10, after joining you are getting the 9, 8 like that. Yeah, you increase that 11, 12, whatever. So here, the main goal of lossy decomposition is often to reduce data redundancy, improve data organization, and optimize query performance even if it means sacrificing some less important details. In this process is typically used when the benefit of simplification outweigh the potential loss of information. So, same way you have to see on the screen steps for lossy decomposition. First step, identify non-essential information. Second step, to remove redundant data. Group related data. Decompose the table. And then accept some information loss. Verify changes. And the last, document changes. Review and refine. So, we'll discuss one by one. Identify non-essential information. It means we have to look at the data in the table and identify any information that is not essential for the main purpose of the database. Then what we'll do, we have to remove the redundant data. It eliminates redundant or unnecessary information from the tables. This could include data that can be calculated from other data or data is rarely used. Then you have to do group related data. Group related data is related to piece of information. This helps to organize the data in more logical way. Then after you have to decompose a table. It means you have to decompose a table in a smaller table based on the group of related data. Each smaller table should contain subset of the original table, except some information loss. Understanding that during the decomposition process, some less important information may be lost. This is okay as long as essential information is preserved. So after decomposition, we are losing some unnecessary, you can say we are unnecessary informations. Then you have to verify the changes. Double check that decomposed table to make surely they still contain the important information needed for the database to function properly. Then document changes. Document the change made during the decomposition process. This helps to keep track of what information was removed and why. Review and refine. Review the decomposed table and refine them if necessary. This ensures that the database remains efficient and effective for its intended use. It means, and also we can say, I have already told, then after decomposition, you have to check whether this certify or not. For that, I have taken also one example. Consider a simple example with a table representing information about the employee in a company. So there in the screen you can see the employee ID, name, department, salary and hire date I have taken. Here the employee ID 101, the name Alice, department HR, salary 5,000, 50,000 and hire date is 15 January 2020 maybe. And then these are the original data for I have taken that. How you will check? The first step you have to, I have already explained just a few minutes before, identify the non-essential information. In this example, let's consider the hire date. It means when the employee is hired. As non-essential information, while its value for tracking employee history, it is not essential for the basic employee management task. Second step, to remove the redundant data. We will remove the hire date attributes from the table since it considered redundant for our simplified database. So you can see on the screen what in the previous relation it was the 5 attributes, here only 4 attributes. The third step, to group related data. We are focusing on simplify the table. We would not group any related data for this example. Fourth, decompose a table. Since our goal is to keep this example simple, we would not decompose a table further. In more complex scenario, you might split the table based on the department or job role, for example. So depending on the, you can split that into relation. So you have to check whether it is it will satisfy all the 3 anomalies. It will not. You have to decompose otherwise. So the fifth step some information loss. By removing the hire date attributes, we are accepting some loss of information about employee history. However, for basic employee management tasks such as payroll or department assignment, this loss may be acceptable. Verify changes. We will review the update table to ensure that it still contains the essential information needed for basic employee management tasks. Next step is to document changes. It's important to document the removal of the hire date attributes from the table for transparency and further references. Review and refine. In this simple example, there is no need for further refinement. However, in a real-world scenario, you might refine the decomposition based on the specific need of your database. Depending on the requirement, you may decomposition based on a specific need of your database. Take the next example. Consider another example with a table representing information about the product in the store. In the original table, there are 5 attributes. One is product ID, and the next is product name and category, price and stock. You have to check, verify it is lossless. So there are 7 steps I have explained. So you have to check one by one. Step 1, identify non-essential information. Here you can see on the screen that stock is a non-essential. So for this example, let's consider the stock attributes as a non-essential information. While it is important for inventory management, for basic product information, it may not be necessary. The next step, remove redundant data. Remove redundant data. We will remove the stock attributes from the table since it considered redundant for our simplified database. So here you can see on the screen, here the only four attributes containing tables: price, category, and product name and product ID. The third step, group related data. We are focusing on simplifying the table. We would not group any related data for this example. Decompose the table. So we have to decompose it. Similar to the previous example, we would not decompose the table further for this simplified example. Step 5, accept some information loss. By removing stock attributes, there are accepting some loss of information about product inventory level. However, for the basic product information, this loss may be acceptable. Step 6, verify changes. We will review the update table to ensure that it still contains the essential information needed for basic product management tasks. Then document changes. 7, document the removal of the stock attributes. Document the removal of stock attributes from the table for transparency and future reference. Review and refine. In this simple example, there is no need for further refinement. However, in a real-world scenario, you might refine the decomposition based on the specific need of your database. The third example, I've taken consider an example with a table representing information about the customer and their order in an online store. So here the attributes are about 7: order ID, customer name, product ID, product name, quantity, and order date. Okay. You check step by step. First, we have to identify non-essential information. For this example, let's consider the customer name attributes as a non-essential information. While it is helpful for identifying customer for basic order management tasks, the customer ID may be sufficient. If you have a customer ID, you are able to find in that. So in one table, you can make a customer ID and the name. So this table is not essential. The next step, to remove the redundant data. So we will remove the customer name attributes from the table since it considered redundant for our simplified database. So you can see on the screen, only this table contains 6 attributes containing order ID, customer ID, product name, quantity, and order date. Then we have to switch to third step, group related data. Since we are focusing on simplifying the table, we would not group any related data for this example. The fourth step, decompose the table. Similar to the previous example, we would not decompose the table further for this simplified example. The fifth step, accept some information loss. By removing the customer name attributes, we are accepting some loss of information about the customer name. However, for basic order management tasks, this loss may be acceptable since we still have a customer ID to identify the customer name. So, if you know the customer ID, you are able to find the customer name. The sixth step to verify changes. We will review the update table to ensure that it is still contains the essential information needed for the basic order management task. Next step, document changes. Document the removal of the customer name attributes from the table for transparency and future references. The last, review and refine. In this simple example, there is no need for further refinement. However, in the real world scenario, you might refine the decomposition based on the specific need of your database. Now, let's assess your knowledge and track your progress by giving some thoughtful questions on the crucial topic discussed today. Your answer will not reinforce the understanding but also serve as a valuable gauge of your grasp. The question is, what do you mean by lossless decomposition, and explain in detail. The next question is, describe lossless decomposition. Next question, what is the advantage of lossless decomposition? What are the advantages of lossless decompositions? As we wrapped up today's discussion, I hope today's discussion will enhance your knowledge about the decompositions, and it will helpful for design a modern database. Thank you.